Again, another Hamilton problem. In the triangle ABC, the angle ABC is right angle A with this angle. This angle is right angle. And the points P and Q lie on AC. So P and Q are along the line AC. And BP is perpendicular to AC. So BP is perpendicular to AC. This BP is perpendicular to AC. And this BQ bisects the triangle ABP. BQ is bisecting the triangle ABP. BQ is bisecting the triangle ABP. You have to prove that CB and CQ are equal. C to B and C to Q are both equal. That's what you are supposed to prove. Okay, now what will be the value of this angle? Yeah? This angle is going to be 90 minus 2 times x. Yeah, why? Because if we look at this triangle ABP, ABP is a right angle triangle here, 90 degree here. Okay, from 90 degree, if I subtract 2x, that angle is going to be 90 minus 2x. Okay, now what will be the value of this angle here? Again, triangle BQP is right angle triangle, from which if we subtract x and subtract 90, that angle is going to be 90 minus x. Oh. Now, if you look at the fact that CB and CQ are equal, CB and CQ are equal, that makes triangle CBQ as isosceles, and this angle 90 minus x is also going to be the value of angle QBC. So this angle is also going to be 90 minus x. Okay, both of them are 90 minus x. Yeah. And so your CQB and CBQ are both 90 minus x each. Yeah. So which makes this triangle BCQ as isosceles. Did we go around in a bit of circle? CBQ. No, that's fine. CBQ and CQ are equal. CB and CQ are equal. So that's all fine. BCQ is basically isosceles. Yeah. This side and that side are equal. And your CB is equal to CQ. That's what you're supposed to prove. CB is equal to CQ. Now, I think we just went around a circle. So there's something which we missed out. I'll go back a bit. So this angle is 90 minus x from a from a 90 degree right angle triangle. A 90 subtracted and x subtracted. This will give you 90 minus x. Next, this angle here, the value of this angle is going to be 90 minus x here. Angle QBC is 90 minus x. This is 90 minus x. And that angle is also 90 minus. This angle is 90 minus x. That angle is 90 minus x. Together it makes it a right angle triangle in which these two sides are equal. CB and CQ are equal. And hence proved. You okay? Everyone okay with that? Yeah. The diagram shows a triangle and two of its angle bisectors. Yeah. Do you know what is the meaning of angle bisector? This is an angle bisector, which means it divides the larger angle into two parts and both the parts are equal. This is an angle bisector because it divides a large angle into two parts and both the parts are equal. You need to find the value of x here. Yeah. So let's assume that, because there are angle bisectors, so these two angles are going to be the same value. Let's call them as y and y, and let's call them as z and z. Okay. So we'll make a table. We'll look at the triangle from our outer triangle. If you look at this outer triangle, the sum of x plus 2y plus 2z is 180. And that gives you actually 2 times y plus z is 180 minus x. And then from the inner triangle, which is this one, the sum of y, z and 2x is 180. Okay, which means y plus z is equal to 180 minus 2x. Now, if you compare these two equations, this equation is exactly twice if you look at the left hand side, this part is twice that part. Yeah. So for the right hand side also, this 180 minus x is actually equal to 2 times 180 minus 2x. Yeah. And so you can eliminate by left hand side by writing this is equal to 2 times that. 180 minus x is 2 times 180 minus 2x. Open the bracket and you'll get 3x is 180, and hence you'll get the value of x as 60 degree. Answer is 60.
Could you explain again from inner triangle, please?
Yeah. So in the inner triangle, which is this one, the sum of y plus z and 2x is 180. 2x plus y plus z is 180. Yeah, this is equation 2. Write y plus z as 180 minus 2x. Equation 2. Now just compare the equation 1 and equation 2. On the left hand side, this is 2 times that. So this 180 minus x should also be 2 times 180 minus 2x. And that's what your equation is by eliminating y and z. That 180 minus x, right hand side of the first equation, is 2 times the right hand side of the second equation. You okay with that? You okay with the equation? Yeah?
How did you get that?
See, I'm just saying, compare, how did you get what? The equations or this particular step? That step, you mean, right?
This step?
See, if you just visually compare the left hand side of equation 1 and the left hand side of equation 2, what do you observe? What do you observe? This is 2 times
It's
y plus z.
double than the other?
Exactly. So this, if the left hand side is of equation 1 is double the left hand side of the equation 2, the right hand side of equation 1 is also double the right hand side of the equation 2. That's exactly what we are doing. Right hand side of equation 1 is double the right hand side of the equation 2. That's how you get the equation. That's how you get this.
Okay, thank you.
So, upon opening the bracket and simplifying, your x will turn out to be 60 degree. Answer is, the value of x is 60 degree. Okay? Everyone okay? Yeah. Okay. In the triangle quadrilateral ABCD, AB and BC are the same. And BAC is 60 degree and CAD is 40 degree, and AC and BD cross at point X, and BXC is 100 degree, and you need to calculate BDC. Well, the problem with this problem is the diagram is not given. So you have to draw the quadrant ABCD in a step-by-step process, obeying each of these conditions. You may not be able to incorporate all the conditions in the single go. So it will be the drawing the diagram is going to be an iterative process till one by one you have incorporated every bit of information. And if you do so carefully, which is a task in itself, you are going to end up in a diagram which is like this. Yeah, it's going to be like that. BAC is 60 degree, BAC is 60 degree, AB and BC are equal, AB and BC are equal, BAC is 60 degree. Yeah. So you get angle triangle ABC is going to be equilateral triangle. And your D is going to be somewhere here. So the A, B, C and D is going to be somewhere here. And that is going to be 40 degrees, CAD. CAD is 40 degree. Yeah. And if I connect the D and B, the intersection point is called at X. Cross at X, the AC and BD cross at X. AC, BD, they intersect at X. You need to calculate the BXC as 100 degree. Yeah, no, BXC is already given. BXC is 100 degree. You need to calculate the value of angle BDC. BDC. You need to calculate the value of this angle. Yeah. By the way, how will you go about it? If you look at this particular triangle, 160 makes 160. So the small angle here is going to be 180 minus 160, which is 20 degree. This angle is 20 degree. Now, out of the larger angle 60 degree, if I take a chunk of 20 away, the remaining part, angle A, B, D is 40 degree. It's going to be 40 degree. Okay, now in the larger triangle ADB, this is 100, this is 40. Collectively, this angle and that angle is 140, which means the third angle is going to be 40 degree as well. And that makes this large triangle ADB as isosceles with a 40 here and a 40 there, which means AB and AD are also equal. Yeah. Now with this, if I find this particular angle from 180 in a straight line, if I take 100 away, the remaining portion is going to be 80 degree. And now if I connect this DC, yeah, if I connect this DC, this angle here, let's assume that let's call this BDC to be angle P. BDC, let's call this angle to be P. Going to be P. Now, if you look at the triangle ACD, it is an isosceles triangle. The triangle A, C, and D is an isosceles triangle because this side AC we have proven it to be equal to that side AD. Yeah, AC is proven to be equal to AD. You know why is it so? Because this side AC is equal to CB is equal to AB as part of an equilateral triangle, and we have also proven that this AB and AD are equal. Yeah. So basically, what it means is this entire triangle ACD, triangle ACD is an isosceles triangle. Okay. And so, if you look at ADC, A, D, and C, it's going to be the same as ACD, both being equal to 40 plus P. So this angle is 40 plus P, that angle is also going to be 40 plus P. Now, if you look at this triangle, which is highlighted here, the sum of 80 plus 40 plus P plus another P is going to be 180 degree, which gets you an equation. Upon solving that equation, uh, the value of P is going to be 30 degree, and that is the answer of the question. Find the value of angle BDC, which is 30 degree. Okay, everyone?
Could you explain that again, please, from XCD?
From XCD. Yeah. So if you look at this XCD, are you okay up to this point here? Before this, are you okay? 40 plus P here. Angle ADC and ACD are both 40 P each. Angle ADC is 40 P, and angle ACD is also 40 plus P. Sorry. Okay, so now if you look at this triangle which is highlighted here, this is 80, this is 40 plus P, and this is P. Collectively, the sum of all the three angles is 180 degree. And that means your 2 times P is 60, means value of P is 30 degree. Okay? I'm okay with that? Okay. The diagram shows an equilateral triangle ABC here, and two squares AWXB. AWXB is one square, and AZYZ. AYZC. AYZC is another square. And you have to prove that the triangle AXZ is equilateral triangle. AXZ. AXZ is an equilateral triangle. That's what we're supposed to prove. Okay, so now if you look at the this angle here, ZAC, that is a diagonal of a square, so that's 45 degree. And that larger angle of an equilateral triangle is 60 degree. Okay, this is 60 and that is 45. Now the difference between 60 degree angle and 45 degrees, so this small angle BAZ is 15, is 15. And so this angle BAY is from 90 degree. If I subtract 60, that angle is going to be 30 degree. And what will be this angle? Again, this is a diagonal of a square, so that angle BAX is 45. Yeah, and so the remaining portion YAX is 45 minus 30. That gives a 15 degree angle here. Now, uh, if you look at the side AC, yeah, AC of the square of this square, side AC, this square, yeah, is actually equal to side AB. This side is equal to that side because both the equilateral, both the squares are having the same side length, just shared with the equilateral triangle. Okay, so and so side AC is equal to side AB. Side AB and side AC are equal, and that makes the side, it's also equal to side AW. Because the square, all the four sides are equal. So this side AW is also equal. This side is equal to that side is equal to that side. Okay. So pulling it all together, you find that the two squares are exactly identical. They are congruent. It's by ASR rule, 90 degree, all the four angles are 90 degree. And two pairs of the sides are equal. That makes it a congruent set of square. And a congruent set of square, the diagonals are also going to be equal, of equilateral, of equal length. Yeah. And hence, your AZ and AX are equal. AZ and AX are equal. And if I connect this line, Z and X, what kind of triangle are you going to get? This AZ and AX are equal. That makes it a isosceles triangle. And the value of that angle is also equal to 60. How? If you find the angle between Z, A and X, a good portion of it is 45 here. Yeah. And on top of that 45, if I add this portion of 15 degree, collectively, this is uh, a triangle in which the two sides are equal and their angle is 60 degree. That makes it a perfect equilateral triangle. That makes it a perfect equilateral triangle. Are you okay? Okay with that? You okay? Yes, give me a second. Yeah, just give me 2 minutes. Yeah, I'll be back with you. In the meantime, have a go at this question. Hello. Hi, folks. Okay. So the C3 of 2019, Kelly third question of 2019. The triangle ABC is isosceles. By the way, they'll not give you the triangle. So if a question in this figure is not given. So the triangle ABC is isosceles with AB and BC are equal. Yeah. So this triangle AB, wherein AB and BC are equal. These two sides are equal. The point D is a point on BC. The point D is somewhere on this BC between B and C. So the point D is somewhere between B and C. So that AC, AD, and BD are all equal. AB and BC are already equal. So point D is somewhere here, wherein A to C, A to D, and B to D all are equal. They're all equal. Now you need to find the size of the angle ABC. You need to find the size of angle ABC here. Okay, so now in this triangle, we'll make a table, the triangle and the angle value and the reason. So let's assume that BAC is x degree. BAC, this angle is x. Okay, this angle is x. Now, if you look at the triangle ABC, because these two sides are equal, the, and this angle is x, angle BCA is also going to be equal to x. BCA and BAC are equal to x. Reason being, it's an isosceles triangle with side AB and BC being equal. Okay, now what will be the value of this particular angle, angle ABC? It is going to be 180 minus 2 of x. Yeah, again, it's an angle of an isosceles triangle. Now, next is, if you look at this angle, angle ADC, yeah, because these two sides are equal, these two angles are equal as well. So angle ADC is going to be same as ACD, which is x degree. Yeah, because it's an isosceles triangle. Similarly, if I have to find the angle BDA from a straight line of 180 degree, if I subtract an x, that angle BDA is 180 minus x. It's going to be 180 minus x. Okay, from a straight line. So now you have how do you find this angle? It's an isosceles triangle. So in order to find this angle from 180, if I subtract an x and x, this angle is going to be 180 minus 2x. Yeah, angle ADC, this angle is 180 minus 2x. It's a common angle in the isosceles triangle. Okay, now your objective is to find ABC. Yeah, ABC. You need to find the value of 180 minus 2x. You need to find the actual numeric value, not just in terms of x. Okay, because x is just an assumed value. So now this angle we have found 180 minus 2x. This angle here is 180 minus 2x. Now, what will be the value of this angle? From a larger angle x, if I subtract a smaller angle 180 minus 2x, your BAD is going to be angle BAD is going to be 180 minus 2x. How do we get 180 minus 2x? From the fact that BAD is an isosceles triangle. So whatever the value here is also going to be the value here. So angle ABD is same as angle BAD, both being 180 minus 2x. So this angle is also 180 minus 2x. Okay.
Why
Now,
is that angle also 180 minus 2x?
because triangle ABD is isosceles, these two sides are equal. You've given that AC, AD, and BD are equal. So BD and AD are equal, making it an isosceles triangle. And the common angle is 180 minus 2x here. The same will be equal to that, 180 minus 2x as well. Okay. Now, pulling it all together, Oh, wait. Is there any question? Sorry. Do you have any doubts so far? You okay?
Why is
Yeah.
why is BCA X? Is that what we assumed at the start?
We assume BAC to be X. BAC to be X. And BCA.
Okay, thank you.
BCA is also X because it's an isosceles triangle. Yeah. So we were up to this point. This is 180 minus 2x, and that is also 180 minus 2x. Angle ABD and angle BAD both are 180 minus 2x. Okay. So now, uh, the equation that you get is that in this large triangle, the sum of three angles is 180 degree. Okay. So you get 180 minus 2x here plus a 180 minus x here and a 180 minus 2x here. The sum of all the three angles is 180 degree is equal to 180 degree. So this plus that is 180. Open the bracket, you'll cancel out a few things and you'll be left with 360 being equal to 5x. Okay. So your x is 72. Yeah. Yeah. So your ABD is 180 minus 2x, which gives you 180 minus 2 times 72, which gives you 36. Yeah. So angle ABD is 36. Yeah. I think that's what you're supposed to find. Supposed to find. I think the question was find the size of angle. Actually, the question was to find the size of angle ABD, not ABC. ABD. But it is the same as angle ABC. ABD is same as ABC. Yeah. Which is 36. Are you okay? Everyone okay with that? Okay, now here the star octagon shown in the diagram is beautifully symmetrical, and the center of the star is at the center of the circle. The center of the star is exactly overlapping with the center of the circle. Very symmetrical. Okay, given that one of the angles is 110, this one, you need to find the value of x. Now, if this is 110, if you make a full circle around this point, you get 360. From 360, if I take 110 away, this portion is 250. Now, because of the basic inherent symmetry of this figure, you can put all these angles at x and 250 each. Yeah. So this is x, this is x, this is x, this is x. This is 250, this is 250, this is 250, and that is 250. So 4 times x and 4 times 250 makes an 8-sided polygon whose sum of all the internal angles is 8 minus 2 into 180. Okay. Open the brackets, you get 4x and you get 1000, and this is 1080, from which if you subtract 1000, your 4x is going to be 80 degree. And hence, x is going to be 20 degree. Very simple question actually. You okay? Everyone okay? First question in 2004 paper. You okay, everyone? Yeah. Okay, in the rectangle ABCD, yeah, again the diagram is not given, so we'll draw it point by point. ABCD is a rectangle. The midpoint of AB is M. Yeah, so ABCD is a rectangle and midpoint of AB is M. So we'll put an M here. And AB to AD is 2 is to 1. So AB to AD is 2 is to 1. So this side is twice that side, which means A to M, which is half of AB, A to M is same as M to B, which is same as A to D. Okay. Now the point X is such that the triangle MDX is equilateral. So M, D, and X. X could be like this to make it an equilateral triangle, or it could be like that to make it an equilateral triangle. Yeah. Now, which one of these two options is correct? They have given with X and A lying on the opposite sides of the line. X and A should be lying on the opposite sides of the line. So, which means the X has to be somewhere here. X is to somewhere here. So that A and X are on the opposite side of the line MD. Okay, now this is also an equilateral triangle. Yeah. You need to find the value of angle XCD. XCD. You're supposed to find this particular angle. Equilateral triangle, all three sides are equal. This angle is 45 degree. This angle is 60 degree. And this angle is also 60 degree here. And because it's a 45 degree here, this angle is 60 minus 45, which is 15. Okay, 15 degree here. And in an equilateral triangle, all the three angles are 60. So this is 60. Yeah. And this is 75. Yeah. Because in this triangle, M, D, at this point, 60 plus 45 makes it 105, which subtracted from 185 will give you, from 180 will give you 75. Okay. So this portion is also 75. Okay. And so if you look at this triangle, if I draw this triangle XMC, uh, you get uh, this MC is equal to MD, which in turn is equal to MX, which means MX and MC are equal, making this triangle MCX as an isosceles triangle, in which this portion, yeah, is going to be 30 degree. Why? Because from a 180 degree, if I subtract 45, if I subtract 60, if I subtract 45, this will be left as 30 degree. Okay, so you get a right angle, you get an isosceles triangle if these two sides are equal and the common angle is 30. Both the uncommon angles or both the equal angles are going to be 180 minus 30 divided by 2, which gives you 75 each. Okay, so both this angle is 75 and that angle MCX is also 75. And what does it tell you? If this angle is 75, already proven, this angle is also 75, it makes this triangle to be an isosceles triangle. Okay. And so it's a 75, 75 and a 30 degree angle here. Okay. Which means angle XCD is equal to 30 degree as required in the question.
Could you explain that last part again, please?
So from what point? You okay up to this point? Why this is 30 degree? From 180, if I subtract 45, so 60 and 45, I'll be left with 30 degree here.
How do we know that the two angles on the sides are 45?
Well, it's a diagonal, right? See, M is the midpoint. So AD and equivalent of M here will make a square in which the diagonal is 45 degree, right? You get it? So this AM and AD are equal. Yeah, because AB is 2 times AD. So this AM and AD are equal. And this angle is 90 degree. That makes it a right angle isosceles triangle in which a 45 and a 45 and a 90. This angle is 45. Yeah.
Oh yeah, I understand that bit now.
So are you okay? Everyone okay? Now the responses have started to die down. Are you all fine? Yeah.
Could you explain the bit after that, please?
Okay, that's fine. All right. So from a straight line, a line of 180 degree, if I subtract 45 here, another 45 here, I've taken out a chunk of 90 degree. And from remaining 90 degree, if I subtract 60 degree here as well, I get a 30 degree here. Okay, so MCX is a triangle in which the common this angle is 30 degree and these two sides are equal. Why these two sides are equal? Because MC and MX are already equal. MC and MD are already equal because of the symmetry. And MDX is a equilateral triangle. in which this side and that side are equal. And hence this and that are equal, which makes the triangle MCX as isosceles. Common angle is 30 degree. So both these angles are 75 each. So this angle is 75. Now, if this angle is 75, what can we say about this triangle? A 75 here, a 75 here makes an isosceles in which this side is same as that side. And the common angle is 30 degree. 75, 75 subtracted from 120 will give you 30 degree here. Okay. And hence XCD, which is supposed to find, is 30 degree. Okay, everyone? Yeah. Okay. The triangle ABG has a right angle at B. No diagram given. Okay. The points C and E lie on the side AG, and points D and F lie on the side BG. So that the six line segments AB, BC, CD, D, E, F, and FG are equivalent. Calculate the angle of AGB. So we'll make a triangle ABG, ABG, right angle at B. The point C and E lies on AG. On AG, you get point C and point E. And D and F lie along BG. So D and F are along the line BG. So that the six line segments AB, BC, CD, DF, and FG are all equivalent. AB is equal to BC, is equal to CD, is equal to DE, is equal to EF, and also equal to FG. All these sides are equivalent. All these sides are equivalent. Okay. Now you need to calculate the value of angle AGB. AGB. You need to find the value of this angle. Now, are you okay with the way we draw the diagram, incorporating every bit of information? It's going to be iterative process for you. Yeah. So you'll come to that final shape after a few iterations. Just be open to that. Okay. So now here, let's assume, because we are not given the value of any of the angle, let's assume that AGB. Yeah. Let's assume that AGB is x degree. And you need to find the value of x. Okay. Now, in any given triangle, yeah, the corresponding angles in an isosceles triangles are all equal, isn't it? So in this isosceles triangle, wherein this side and that side are equal, if this is x, then that angle is also going to be x. So your angle FEG is going to be equal to x. FEG is going to be equal to x. Now, if you uh, you also know that in a triangle, the exterior angle is equal to the sum of the opposite interior angle. So this angle is the sum of x and x. So this angle EFD is going to be equal to 2x by using this one. Yeah, this is a 2x here. Now, by the same first logic, in this triangle, these two sides are equal, and hence this angle is going to be that angle. If this is 2x, then angle EDF is also going to be equal to 2x. Yeah, that's also going to be equal to 2x. Okay, you have to get to 2x here. Now again, this angle, angle CED, is going to be the exterior angle of triangle EDG. So this 2x plus that x should be equal to that 3x. Okay, so your angle CED is 3x. Is 3x. Now about this triangle CDE, these two sides are equal, making it isosceles. So if this is 3x, and that angle is also going to be 3x.
Why is it 3x?
Which one? This one. It's an
Angle
exterior.
CD.
Exterior angle is the sum of two opposite interior angles. If you analyze the triangle DEG, the sum of interior angles 2x and x is equal to the exterior angle 3x. Okay.
Okay, thank you.
Again, Isosceles triangle, if this is 3x, that is 3x as well. These two sides are equal. So this is also 3x. Yeah. And then again, you use the fact that this angle CDB, if you analyze the triangle CDG, the sum of 3x and x should be equal to 4x here. The sum of exterior angles is equal to the exterior angle is equal to sum of the two opposite interior angles. Yeah. So this 4x is 3x plus x. So that's a 4x. Again, these two sides are equal. If this is 4x, that angle is also going to be equal to 4x. The DBC is also equal to 4x. DBC is 4x. Okay. Lastly, what will be the value of this angle? Angle ACB. If you look at the triangle CBG, a 4x here and an x here together will make it 5x as the exterior angle here. So angle ACB is 5x. ACB is 5x. And if this is side is equal, these two sides are equal. If this is 5x, that's angle CAB is also 5x. It's also going to be equal to 5x. Now, how do we put it all together? You need to find the value of angle AGB. AGB. If you look at this large exterior triangle, large outer triangle, a 5x here plus a 90 here plus an x here is 180, and hence x plus 5x is 90. Yeah, and hence 6x is 90, and hence x is going to be equal to 15 degree. Yeah, your angle AGB is 15 degree. Is it fine, everyone? You okay, everyone? Yeah. Okay, now in the rectangle PQRS, again, no diagram given. All these questions have to be done very carefully because you have to draw the diagram incorporating every bit of information given. The rectangle is PQRS. So this is the rectangle PQRS. Okay. The side PQ has a length of root 2. P to Q is of the length root 2. And side PS is a length of 1. So this is root 2 and this is 1. Okay. Let the circle with the center Q and passing through R meet the PQ at X. So we'll make a circle with the center Q and it is passing through R. So the circle is centered at Q and it is going to pass through R. And it meets the PX, it meets the PQ at point X. So this is how the circle will look like. This is 1, this is root 2. Yeah. And you draw a circle with a center here whose radius is QR, and it will cross this PQ at the point called X. You need to find the angle PSX. PSX. You need to find this particular angle. Okay. So now what will be the value of the radius? Radius is going to be 1, because this is 1 here. Yeah, this is 1. Radius is 1. Now, this portion is going to be root 2 minus 1. Yeah, so this portion is going to be root 2 minus 1. So, this is 1, this is 1, root 2 minus 1. No, you're not allowed to use compass. You have to draw it very, not exactly circular, but you have to draw a rough diagram. Okay. So now if I make a triangle here, connect the X and R, what kind of triangle you get? A 90 degree and these two sides being equal. It's a right angle isosceles triangle with a 45, 45 and 90 degree. Okay. So this is 45. This is also 45 and you get a 45 here as well. So all these angles are 45 degree each. Yeah. And so RXQ is a right angle isosceles triangle. It's a right angle isosceles. This side is equal to that side, and these two angles are 45 degrees. Okay. So your Rx is actually equal to PQ. Rx is equal to PQ, which is actually Rx. Sorry, yeah, Rx is equal to PQ. Yeah, Rx is equal to PQ. Yeah, because this is 1 and this is 1, so this will be root 2, and this root 2 will be equal to that root 2. Okay, both being equal to root 2. Okay, now how about this line? The line which I've just drawn. From X to S, if I connect, yeah, that Rx is going to be equal to SR. That Rx is going to be equal to SR. Rx is going to be equal to SR. How's that, sir? Yeah, yeah. We have calculated the SR to be root 2 originally, and this Rx is also root 2. So that makes it an isosceles triangle. These two sides are equal. And so, if in an isosceles triangle, if this angle, common angle is 45, the remaining angle is by 180 minus 45, which is 135, divided equally among the two. Okay. So both these angles are going to be 180 minus 45 divided by 2, which is 67.5 each. Okay. And this is 67.5 from a right angle triangle 90. If I subtract 67.5, I'll be left with angle PSX being equal to 22.5. Okay. So angle PSX, which you are supposed to find, is 22.5. You okay, everyone? Everyone fine? Hmm. Okay, the diagram line, again, no diagram given here. No, the diagram is actually given there. They're referring to the diagram. In the diagram, line CD is parallel to AB. And M is the midpoint of line XZ. M is the midpoint of line XZ. Yeah. And DXM is 50 degree. DXM is 50 degree. MZA is 25. MZA is 25. Now you need to find angle MAZ. MAZ. You need to find this particular angle. And CXA. CXA. So you need to find this angle and that angle. And show the explanation, showing the explaining each step in the working. So you explain how you got arrived at it. So first of all, what will be the value of this angle? Angle AXM is actually equal angle is actually equal to angle TRP. What is it TRP? Is there no TRP here? Interior angles of parallel lines. So these two sides are parallel. So this is 50 degrees. So this is also 50 degree. Yeah? This 50 and 50 each. This is 50 each. Okay. Now, what will be the value of this angle from 180? If I subtract 50, that will be 130. Yeah. This angle is going to be 130 from a straight line of 180. If you subtract 50, it is 130. Okay. Now, if you look at this triangle, this triangle AMZ, the sum of all the three angles is 180. 180 minus 30 and minus 25 will give you this angle MAZ as 25 as well, which makes a 25 here angle here and a 25 here angle as well, which makes this triangle to be isosceles. And so AM and MZ are both equal. AMZ is going to be an isosceles triangle. So now, because in this triangle XAM, we know that MX is equal to MZ, which also happens to be equal to MA now. So these two sides are equal, making it an isosceles triangle in which the common angle is 50. So the remaining two angles are going to be 180 minus 50, which is 130 divided equally by 2, which makes both these angles as 65 each. Both of them are 65. Okay. So you have found this angle to be 65. This is 65 as well. Now what will be angle CXA? From 180 degree, if I subtract a 50 here and a 65 here, angle CXA is going to be 180 minus 65 minus 50. That gives you a 65. Okay, it's again going to be 65. So we have uh, calculated MAZ as 25 here and CXA as 65. Yeah, as required by the question statement. Are you okay with the working? You're fine? Yeah.
Did the question tell you that the two lines were equal, that XM and MZ were equal?
It says that two sides are parallel. CD and AB are parallel. Which two sides you are equal? Yeah, it was given in the question statement. Yeah, it is given.
Okay, thank you.
M is the midpoint of XZ. M is the midpoint of XZ. Yeah. Okay. Last couple of questions and we'll stop. Yeah. In the triangle ABC, angle BCA is 90 degree, and point E and F lie on the hypotenuse of AB such that AE is equal to AC and BF is equal to BC. You need to find angle of BCF. No diagram given. No, in fact, the diagram is actually given here. Yeah. So here in this triangle, BCA is 90 degree. BCA is 90 degree. This angle is 90 degree here. And point E and F lie on the hypotenuse AB such that AE is equal to AC. AE is equal to AC. AE is equal to AC. And BF is equal to BC. BF is equal to BC. AE and AC are equal. BF and BC are equal. You need to find the angle ECF. ECF. So you basically have to find the value of X in this diagram. Okay. So because BCA is 90 degree, yeah, the sum of x plus y plus z, this angle is 90 degree, which means x plus y plus z is 90 degree. Yeah, that's your first equation. The sum of all the three angles x, y, z is 90 degree. Then your BF is equal to BC. BF and BC are equal, which makes this triangle as an isosceles triangle. Okay, BF and BC are equal, which means BCF is isosceles triangle, which means what will be the value of this angle? It will be same as x plus z. Yeah, so this angle is going to be x plus z. Then we'll use the fact that you know this particular angle, because these two angles are x plus z, the third angle is going to be 180 minus 2 times x plus z. X plus z here and x plus z here. 2 times x plus z is subtracted from 180 for this angle. Now we'll use from 180 from a straight line here, from a straight line 180 degree. If I subtract x plus z, angle AFC is going to be 180 minus sum of x plus z. Yeah, and so
But how did you know that BF was equal to BC?
BF.
Oh, it says in the question, sorry, I couldn't see that.
Yeah, that's what is highlighted here. Okay, so this angle is 180 minus x plus z, 180 minus bracket x plus z. Now, what will be the value of this angle? Angle FEC. FEC. That is going to be the exterior angle of the triangle of the triangle ECB. The sum of z and 180 minus 2 times x plus z will make it as 180 minus in bracket 2x plus z. Exterior angle of sum of these two angles. Okay. Yeah. Now we'll use we need to find the value of angle A here, BAC. Yeah. That angle from the triangle ACF, from 180, if I subtract y and if I also subtract 180 minus x plus z, I'm going to get this value to be x plus z minus y. You can actually calculate it. Can you do it? If I know this is y, if I know this is 180 minus x plus z, what will be the value of this angle? Can you all try it out? Because you know sometimes it's quite a tedious subtraction. You okay? Are you all okay? X plus z minus y. Did you all get it? X plus z minus y. Focusing on this triangle. Okay, I'll assume that you're all okay with it. Yeah, x plus z minus 5 here. Now, because AE and AC are equal, AE and AC are equal, making it a making it an isosceles triangle. Yeah, in an isosceles triangle, uh, your CAE and CEA are both going to be equal. So x plus z minus y here is equal to 180 minus 2x plus z there. Yeah, this, if you open the bracket, to rearrange it, you'll get 3x plus y plus z is equal to 180 degree, which is your second equation. Now, out of this 3x plus y plus z, the x plus y plus z itself is 90 degree. So from 180 degree, the 2x part, if you compare, 2x part is going to be 90 degree because the x plus y plus z is already 90 here. So the remaining 2x is equal to 90 degree. And hence x is equal to 45 degree, which means your ECF, yeah, your ECF, which is actually equal to x degree, is 45.